So we are trying to find the midpoint of the diagonals, okay? What do we get for the midpoint for diagonal AC? 6, 3, okay? What did you get for BD? 6, 3. So they have the same midpoint. So first off, if they have the same midpoint, what are midpoints telling you? Like, why would I test midpoint? What does it prove about the diagonals? That they bisect. So if I have the same midpoint, it's telling me diagonals bisect. So only knowing that I have a four-sided figure where my diagonals bisect, what could you tell me about the quadrilateral? What type of quadrilateral is it? A parallelogram. So we could say here, just from this, I could say A, B, C, D is a parallelogram since the diagonals bisect each other. So all we know right now is I have a parallelogram, that's it. Visually, we may have a better idea, but at least from the calculations, that's all I can tell you. Okay, going on to letter B. So letter B, it said calculate the slope of the diagonals. Keep in mind, slope should always be simplest forms reduced. Remember, magnitude 2 will take your fraction, reduce it for you. What do we get for the slope for diagonal AC? Negative 2/3, good. Okay, how about diagonal BD? 3/2. Okay, so not the same, which is good, because if they were the same, what would that mean about them? Same slope means parallel. They should not be parallel, okay? These are flipped and negated, so what could you tell me about them? They're perpendicular. So now it's saying, okay, based on the fact that this is saying they're perpendicular, right? So I could say here negative reciprocal slopes means we have perpendicular lines. So based on the fact that I have perpendicular lines and they bisect, now what could you call the quadrilateral? So I need a four-sided figure whose diagonals not only bisect each other, but are also perpendicular. You could tell me it is a, rectangles will not be perpendicular, okay? A rhombus. So a rhombus, if I'm thinking diagonals, will have perpendicular diagonals and they bisect. So at this point, I could now make it a little bit more specialized and say ABCD is a rhombus since diagonals are both perpendicular and bisect each other. So keep in mind, anytime you're doing a coordinate proof, you always want a concluding sentence. So that's why on each of these, you did your calculation, show me some sort of a conclusion. Okay. And then for letter C, it's saying we have to calculate the length of the diagonals. So what did we get for the length of AC? And we can keep this in square root. We don't have to get a decimal for this. What did we get for the length of this guy? Square root of, what was it? 208. And what did we get for the length of BD? 208. What do we notice about those? They are equal. So I can say here, they are the same distance, right? Or same length. So they are congruent. So now I have, think about what we had up above. We knew it was a rhombus, right? So if I could take that information, it's saying using what we knew up above, it is a rhombus. But now I have a rhombus with equal diagonals. What can you tell me about the shape? Now what is the shape really? It is a square. So concluding statement, we could say ABCD is a square since its diagonals are, we have three things here: congruent, perpendicular, and bisect each other. Do you have to do a proof of a square like this? Is this the only way that I can prove a four-sided figure is a square? Yeah. Okay, by definition, what is a square? The definition is a quadrilateral with same length, sides, and four right angles, right? Okay, or perpendicular sides. So I can say sides, adjacent sides are perpendicular, and I have four equal sides. If you only do proofs according to definition, you'll be fine. And remember what we said too. The fail-safe way to do a coordinate proof, if you're like, I have really no idea what to do. You do all four distances, and then you do all four slopes, and all of your calculations are there. And when I'm saying four, it's because I'm meaning all of the sides. All of your calculations are there, and then you just have to end it with a concluding statement. So if you're doing this and you can't remember what to do, you can do it that way. Diagonals sometimes are nice if you know the properties, because sometimes it makes it faster. But if you don't know them, it's not the way you have to do it. Okay, any questions on this before we go? All right. So on the back, we have a square, has a side length of 6 inches. Which of the following is the length of its diagonal in inches? So I have a side length, I have a square. And it wants to know the length of its diagonal. How are we going to do this? Keeping in mind that that's a right angle and it's saying how big is that? What are we going to do? I have a right triangle because I have a right angle and I'm looking for the third side, the missing side. What is it? Not 12. Pythagorean theorem. A squared plus b squared equals c squared. You can always do this when you have a right triangle. You only can use this in a right triangle. Okay, which is the c squared? Which is the side by itself? The x, right? The longest side, the hypotenuse, always points towards that one. So I have 6 squared plus 6 squared equals x squared. Okay, what's 6 squared? Okay, so now I have 36 plus 36 is equal to x squared. What's 36 and 36? 72. So I have 72 is equal to x squared. And if we solve for x, we have to square root. And now I see that my answer is not up there. So you have options. You can play what's called the decimal matching game and try and find the decimal answer that matches up with the square root of 72 and find the answer of one of the choices that matches up with that as well. That's an option. I'm going to show you, this is not something required, but it's something nice to know because it can help with calculations, how to reduce these things. Okay. When you are reducing these square roots, the way that we do this, let me do this up here. I want to find two numbers that are going to multiply to be 72 where one is a perfect square. And by perfect squares, I mean things like 4. 4 is a perfect square because when I square root it, I get 2. 9 is a perfect square because when I square root that, I get 3. So I want two numbers that are going to multiply to be 72 where one is a perfect square. 9 and what'd you say? And 8. 9 and 8 will work. 9 is a perfect square. Is there a larger one? What do we think? 36 and 2. So either of those work. My thought would be take the largest one if you can because it's less work. 9 and 8 would work. We would just have to do this process twice. So let me show you with the 36 and the 2. Which one's your perfect square? 36. What's the square root of 36? 6. Can I simplify this 2 at all? Square root of 2? No, get you a random decimal. So simplifying this, now I get 6 square roots of 2, which is your answer. Okay. You could do it with 9 and 8. Let me show you how the square root of 9 and square root of 8 works. So square root of 9 times the square root of 8, those both multiply to be 72. That's okay. Which one's your perfect square? 9, right? So now I'm going to have 3 square roots of 8. Okay, not an answer. So what that means is I have to do it again. So I have to break up the 8. I want two numbers that multiply to be 8 where one's a perfect square. 4 and 2. 4 and 2. Okay, so what happens is this is square root of 4, square root of 2, and all of these are being multiplied. So it's like saying 3 times square root of 4 times square root of 2. What's the square root of 4? 2. So now I have 3 times 2 times the square root of 2. I can simplify the numbers on the outside. What's 3 times 2? And what do we get? Same thing that we got over there. It's just this one, since it wasn't the largest perfect square, you have to do it a second time. That's all. Okay? I will not test you on it. However, it's good to know it does show up on the Regents exam, especially in the form of multiple choice answers. So if you know how to do that process, that's a really good one to have. Okay. This last one that we have here, so diagonals of square ABCD intersect at point E. So from the front, we know that the diagonals are perpendicular. We know that the diagonals bisect. And they're telling us they intersect at point E. We know BE is 10. So if I know BE is 10, what else do you know? DE is 10. What else do you know? AE is 10. And CE is 10. Everything is 10, right? Because the diagonals are equal and they're cut in half. So all 4 parts are going to be the same. It says, so which of the following represents the length of AB? Okay, so I'm looking again. I'm going to just go right here. What type of a triangle is that? If the diagonals are perpendicular, what forms right here? I got a right angle. So what can I do with a triangle with a right angle solving for a missing side? I can do Pythagorean theorem. So same thing that we did up above. Which one this time is your c squared? The 10s or the x? The x, that's your hypotenuse. It's across from the right angle. So I have 10 squared plus 10 squared is equal to x squared. So what's 10 squared? Okay, so if we add that up, I get 200 equals x squared. So now again, we're in that situation. You can play decimal matching game, and you can find out which one of those answers is going to equal the square root of 200. Or I could find 2 numbers that multiply to be 200, where one is a perfect square. And try and find your largest. Think about what we just did back here. Isn't 100 a perfect square? How many 100s do you have? You have 2. So shouldn't I be able to say 100 times 2? All right, well, what's the square root of 100? 10. 10 square roots of 2, what's your answer? Okay. Questions? I can help you with on that. Anything I can help you with at all. Bless you. Okay, go grab a quick break. We're going to come back. We're going to do a little bit of stuff with squares, a little bit of stuff with triangles.